yeah, we've been looking at just like straight equations, right? So just taking the chain rule, just like with normal equations. However, remember that we also have some more like conceptual type problems, which is going to be stuff. So notice this again, this is just my chain rule, okay? However, some of the stuff that we see might have functions in it. Okay, so we could see stuff in function notation when we're taking our derivatives. Okay, but we're still going to treat it the same way. Alright, so notice that I'm trying to take the derivative of f. Agreed? Okay, f has an x squared, and it also has this other function g. So if I have a function inside of another function, when I take the derivative, I have to use the chain rule. Yes? That's the whole reason why we have our chain rule. The only difference between this and what we were doing before is that I just don't know what g of x is. It could be a square root of something. It could be x squared plus stuff. We don't know what it is, so that means that our answer is going to have g of x's and g prime of x's in it, which is going to leave those in there. Yes? Okay. Now, first off, it might be helpful to rewrite this as what?
1 over gx to the negative 1.
There you go. So g of x to the negative first power. Okay. So now, what operation is happening between my x squared and my g of x stuff? Multiplication, which means we have to use our product rule whenever I take my derivative. So I'm going to take the derivative of the first, which is what? 2x. Then I'm going to leave my second part the same, so just g of x to the negative first. Then I'm going to add, and I'm going to take my first one and leave a 1. And now we're going to take the derivative of the second one. Except, I have stuff inside of other stuff. Yes? Okay? So, remember, I need to take the derivative of the inside. So, what is the derivative of the inside? There you go. So, g prime of x. Okay? Because I don't know what g of x is, so I'm going to leave it as g prime. Okay? And then, if I have stuff to the to the negative first power, what is the derivative of that? Almost.
1 over
Negative stuff to the negative second power. So negative g of x to the negative second power. Because I would bring down my negative 1 and then subtract 1 from my negative 1. So we get negative. I'm going to put a multiplication in here. So negative 1 times g of x to the negative second. Yes?
Where did we get the negative 1 g of x?
So notice that my g prime is the derivative of the inside.
Yeah.
But then I still have to take the derivative of the outside, right? So my negative first is my outside. So like, think of it like if I had, I don't want to use f because my other one's already f. Let's use r. So if I had r of x equals, say, u to the negative first, right? The derivative of that would be negative u to the negative second. And g of x is acting as my u. Does that make more sense? Okay. Yes.
So the one with the negative 1 in front of it is like the derivative, right?
Of the outside part, yes.
So why do we have like the g prime of x?
Because that's the derivative of the inside part. So like think about if I had something like the square root of x plus 1 to the negative first power, right? I would have to take the derivative of the inside stuff,
Yeah.
and then I would have to take the derivative of the outside stuff, right? The only difference is this time I don't know what g of x is. So I can't like actually take the derivative because I don't know what that function is. However, it is a function that has x's in it. So I still have to account for that I have to take the derivative of the inside. But the only way that I can put that is just g prime of x. because I don't know what the inside is. I just know it's a function.
The x squared goes with that. It's not like three separate things. It's like
It's all multiplication.
right. That's right. Okay, I get it.
Okay, but I do want to simplify just a little bit. So this is 2x, and then I'm going to move this g of x to the denominator. Then this is going to become negative x squared g prime of x all divided by g of x to the second power.
Bottom negative? Oh,
No, because I moved it to the bottom.
I see.
I moved the negative to the front. Just because it's easy. Other questions? We want to see another example together?
Yes.
Alright, so on this one,
Oh, was that the answer?
Yeah.
Oh.
because I don't know what g of x is, they didn't give me any other information about g of x. So, like, that's how I have to leave my answer. Because I don't have a g of x. So, that's my final answer.
Okay.
Same thing here. This time they give us t's, okay? However, this is going to be what type of M&M?
Peanut.
It's a peanut M&M because I have my outer is the cube group, my inner is an F of stuff, but then my innermost is 5x. Does that make sense? So we have 3 layers this time. Yes? Now, to start with, it would probably be helpful to rewrite our cubed root as what? To the 1/3 power. Okay? So now, when I take my derivative of t, okay, I need to take the derivative of my innermost part. So what is the derivative of our peanut? 5. So that's what we're going to put first. Okay. Then, what's our next layer? F. What is the derivative of f? Just f prime. We don't, again, aren't given any additional information about that, so that's just what we write. Yes? And then we want to take the derivative of our outermost layer, which is stuff, so the 1/3. So what's the derivative of that? 1/3 stuff. So f of 5x to the negative 2/3 power. So I bring down my 1/3 and then subtract 1.
What was the outer?
1/3. Or to the 1/3 power.
So like use the
Correct.
Okay.
So then again, we're just going to clean it up a little bit. I have a 5 and an f prime of 5x on top. And then we have a 3 and an f of 5x to the 2/3 on bottom. Yes. Do you have a question?
No.
Why did you say wait?
I said great.
Wait, what rule did you use?
We use the chain rule twice.
What? Oh, okay. Hold on.
Question?
No, just let me get a picture. I need to I'm just behind because I'm doing my own method, which is slow, but it helps me understand.
Okay. Yes, no, maybe so. Yes-ish. Yes-ish. Okay. Alright. So, remember that there are 3 different representations that we can look at. Algebraically, which is what we looked at yesterday, and even with our f of x's, right, that's still algebraic because it's still in just normal notation. However, we can also be given a graph or a table. So those are our last 2 representations that we need to look at. And really, the beginning part of it isn't going to be all that different from what we've been doing. I'm just going to take my derivative with f's and g's, okay? But then we're going to use our graph plug in values. Are you with me? Okay. So our first step, like I said, is just we're gonna look at this q first. So my first step is just to take the derivative of q. So I have q prime of x. Right? What is my inside for my q? F of x. We all agree? So what is the derivative of f of x? F prime of x. We don't know what f of x is, and that's okay. So we're gonna leave it in that notation. So then I need to take the derivative of the outside, which is what? G. So I have g prime of f of x, because I don't change my inside. Yes?
No.
Okay. So if it just asks us to take the derivative, that's my derivative. I don't have any other information, like that's as far as we can go. However, they then ask us to find q prime of 4. So I'm going to take my 4, I'm going to plug it in to the stuff that I just got. And this is where our graph comes into play. I'm going to use my graphs to find that information. So when I'm looking at f prime of 4, what am I looking for? No. The slope of the tangent line when x is 4, because it's f prime of 4. So I'm going to go to 4. I'm going to look at my blue graph, and I want to look at what is the slope of that portion of my graph. -1. Okay? Are we all with me on how I got that? That I am looking at the slope of my blue graph at 4. And my slope there is -1. Okay? Slope of the tangent line at 4.
Where'd you get -1 from?
Because the slope of this is -1.
At 4?
Yes.
The y value 4?
X value 4.
Oh, sorry.
Because I'm plugging in, right? That's the x value. F prime of x. So I'm looking at x is 4. But it's f prime, not just f. If it was just f, I would look at just the y value. But since it's f prime, I'm looking at the slope of that portion of the line.
At just 4?
Yeah, but because it's a constant line, it's going to be constant. So that's why they gave us something that has line segments and that's not curvy. Because then we can find the slope. So then for this next part, we do have to do kind of the inside part first. So what is f of 4? 7. Because this time there's not a prime on there, so I'm just looking at what's the y value for my blue graph when x is 4. You all with me?
Yeah.
So then my last step is going to look at the red graph. But what am I looking at the red graph? The slope. Okay? So it would be -1 times, so I'm going to 7. And then I want to look what is the slope of the line for my red graph now at 7. -1/2.
You and I lie.
So my final answer is positive 1. Yes?
Yeah.
Does that make sense?
Actually, yes.
Good. Okay, let's do another one. Okay, we're looking at p of x this time. The only difference is that our f and g have switched places, but I'm still gonna work it the same way. So, what would my p prime of x be?
Can we just repeat the same thing? Like up there. Like with different letters.
Yes.
Please do that.
Hold on. What's my inside? G. So g prime of x.
Okay.
Yes?
Yes.
Are y'all okay with that? Okay. So then, what does it ask me to do with that? Plug in 1. So I have g prime of 1 times f prime of g of 1. So, if I'm looking at G, that's my red graph. What value am I looking for G? But I'm looking for the slope when x is 1 because it's prime. So what's our slope when x is 1? Negative 1/2. Times, I need to work my way inside out. So what is my y value when G is 1? 4. So then what's my last step? Agreed. And what is it? Kind of already found it. But negative 1. Yes?
Sure. Positive 1. Comments?
Hold on a second. So G prime of negative 1/2. There we go.
Okay. I was
Okay. So then F prime of 4 is negative 1. So we get positive 1/2.
Again.
That's okay.
Was that the last one?
No, we have another example. That's not what we do.
So would
One
they be
after.
parallel at that point? On the, would they be parallel at that point? Those points?
Well, they wouldn't.
Because they're different x values.
Yeah, so they wouldn't. We wouldn't say that they're parallel. They each have the same slope at 4 and 1. If like I plugged in 1 and I got 1/2 on both of them, then they would be parallel at 1/2. Okay? But we have one.
Would they be parallel at 1/2? Parallel at 1.
They would only be parallel if I plugged in the same value and got 1/2. Like if I plugged in 1 on both of them, both of the derivatives, they would be parallel. My tangent lines would be parallel because I'm plugging in the same x value and getting the same slope. But those ones I didn't plug in the same x value, so it didn't tell me anything about it. Yeah, it just happened to be that they're both 1/2. Okay. All right, on this next one. Very, very similar. The only difference is now we're going to get our values from the table instead of from the graph. But that's okay. So I'm going to start again by just taking my general derivative. So what is our inside stuff in this case?
TX.
Tx. So what is the derivative of that?
T prime of that.
T prime of x. Again, I don't know what t of x is, so I don't know what the derivative is, so that's okay. So then, what's my outside stuff? Stuff to the third power. So what is the derivative of that?
3t of x squared.
Okay. So that would be my derivative. And then what am I wanting to do with that derivative?
Find it.
Plug in
Negative 1.
negative 1. So I have t prime of negative 1 times 3 times t of negative 1 squared. So I'm using my table at this point. So what is t prime of negative 1? 5.
Nice that they tell us.
It is. But you would not be able to do it if they did not give you the values that you needed. So that's why they give you them. Okay? And then t of negative 1 is what? Negative 4. So I have negative 4 squared. Okay? So we get 5 times 3 gives us 15 times 16. So we get,
A big number.
Yeah, a number is 2 times 16.
okay, so plug
Oh my
into
God,
your
can you solve-
handy dandy
Can you
calculator.
solve this on the board? 240.
240 sounds right. Okay.
What?
Questions on that? Like I said, these are very similar to what you're gonna see on the AP test. Especially like these would be like non-calculator. I mean, it probably give you smaller numbers than 15 times 16, but like the last one and like this one are very much so AP style questions where it gives you like a table or a graph, because then you actually have to understand what does the chain rule mean, not necessarily just like plugging and chugging values. Does that make sense? All right, I think we have a little bit of time left, so I want you to try This last one on your own.
Wow. What is on work? Are we at 3 dash something there? Or still 2? 2.4 now.
It's 5, so.
Well, it doesn't have to be a peanut of an egg.
I need to listen. I'll try my notes right now. But I found out.
What did you get? What did you get for the team? No. FT of X. Oh wait, no. You forgot the outside. TF prime? TF prime. Sorry. Prime of T's. Yeah.
Guys, what's the answer right? Is it like a number? It should be a number? Oh.
Because you're plugging the
What derivative?
So then I'm gonna plug 3 into Alright, sounds like most of us are finished. So, my first step. Bring it back in, please.
Derivative.
My first step is to take the derivative. Okay? So I'm going to take my derivative of the inside, which is t prime of x. Then I'm going to take my derivative of the outside, which is f prime of t of x.
Oh, I was so close.
And then I'm going to plug in 5. So I have t prime of 5 times f prime of t of 5. Then I'm going to use my handy dandy chart. So t prime, looking at 5, is -1. Then I have to plug into the inside first here. So t of 5 is 3. And then I have to plug in that 3 to f prime. So f prime of 3 is 10. So my final answer is -10.
Is the regular F function right now?
Wait, how do we get like equals -1?
Oh, you use the table.
Right, okay.